In this video, I'm going to talk about circles. We're going to start with the definition of a circle and then talk about how to write the equation of a circle. In my next video, Circles Part 2, I'll talk about how we can go from an equation to being able to state information about the circle. But let's jump in. Let's start with the definition of a circle. And it is the set of all points in a plane that are a fixed distance from a fixed point. Let's look at an example. Here's our grid, and we'll say that the center for our circle will be at the point 5, 4, and we'll let the radius equal 3 units. In other words, our fixed point is at 5, 4, and our fixed distance is 3. So let's draw this picture. Here's my origin. 5 will be here and 4 is here. So my center would be right at this point. Now let's see, a radius 3 means from center, I would move 3 in every direction. And of course, every direction doesn't imply just those points, but all points that are 3 units from center. So here's our circle with center 5, 4 and radius 3. What would the equation of this circle be? Well, any point on the circle could be considered to be the point x, y. And we want the equation that says that we want all the points x, y that are a distance 3 units from 5, 4. So let's use our distance formula. Do you remember what it is? The distance between 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, assuming that the ordered pairs of the points are x1, y1, and x2, y2. So for this particular circle, we are going to use the points x, y, and 5, 4. So the distance would equal the square root of x minus 5 squared plus y minus 4 squared. So that distance is supposed to equal 3. Now let's square both sides of this equation. And we'll have an equation that looks like this. 9 equals x minus 5 squared plus y minus 4 squared. Generally speaking, we put the 9 on the other side, so let me do that. So I have x minus 5 squared plus y minus 4 squared equals 9. And we have the standard form of the equation of the circle that has center 5, 4 and radius 3. Now let's do that same problem in general. In other words, we're going to find the standard form of the equation of a circle with center hk and radius r. So let's let this point be our center, and here's our circle. Oop, doesn't look very circular, but it will do. This is the point hk, and this distance is r. And we'll have a generic point xy, and xy represents any point on that circle. So we know that the distance between hk and xy better be r. So let's write our distance formula, the square root of x minus h squared plus y minus k squared equals, in this case, r. And then we'll square both sides. So our equation looks like this. X minus h squared plus y minus k squared equals r squared. And we now have standard form for the equation of a circle that is centered at HK and has radius r. Let's use this information now to write the equation of a circle. So let's do this problem. We'll write the equation of the circle with radius 7 and center negative 19, 3. So we can just pop in the center for HK and the radius for r. So our equation would become x minus negative 19 squared plus y minus 3 squared equals 7 squared. And generally we wouldn't leave that minus a negative, so let's go ahead and write that as x plus 19 squared, and we still have y minus 3 squared equals 49. And usually we present the equation in this way. Let's do another one. Now look what I have added. I have now included the general form of the equation of a circle. What I want to tell you is that when you're trying to find the general form of the equation of a circle, you can just start with standard form and multiply it out. So let's do that. Here's our next example. So here it is. Find the general form of the equation of a circle with radius 2 square root of 6 and center 10, negative 1. So let's start with our standard form. So we'll have x minus 10 squared plus y minus negative 1 squared, and I'm just going to go ahead and write y plus 1 squared equals 2 square root of 6 squared. Now, general form, notice we need it to look like this. X squared plus y squared, and then our linear terms, and then our constant, and we want it set equal to 0. So let's do the work by multiplying out each of those binomials that are being squared. So we'll have x squared minus 20x plus 100 plus y squared plus 2y plus 1 equals 2 square root of 6 squared. And you can come over here to scratch paper if you need to do a little bit of work for that. 2 square root of 6 squared is 2 squared and square root of 6 squared, which gives us 24. So I have equals 24. Now we're going to rearrange it so our quadratic terms are first. So we'll have x squared plus y squared. Now we'll have the negative 20x and the positive 2y. Notice we combine our 100 and our 1. That's plus 101, and we have it equal to 24. So our last step will be just to subtract 24 from both sides. So we'll have x squared plus y squared minus 20x plus 2y plus 77 equals 0. And we have it complete. For our next example, we won't be given the radius. We'll just be given the clue as to what the radius is. So it will be this. Find the general form of the equation of the circle with center 0, 3 and containing the point negative 1, negative 2. So I like to draw the picture because it helps me think it through. Let's draw the point 0, 3 right here. So here's our center, and negative 1, negative 2 is about right here. So I have essentially this as the radius of the circle. My circle would look something like that. Very, very, very roughly. So my task first is to find the radius. But notice the radius is equal to the distance between the points 0, 3 and negative 1, negative 2. So we just need to use the distance formula to find the radius. So let's do it. We have the square root of negative 1 minus 0 squared plus negative 2 minus 3 squared. And remember, you can use those points in either order. In other words, I could have said 0 minus negative 1 squared plus 3 minus negative 2 squared. That would have been fine. So our radius equals the square root of negative 1 squared plus negative 5 squared. And negative 1 squared plus negative 5 squared is 26. So our radius is the square root of 26. So now we know the center, we know the radius. Let's write our equation. We start in standard form. So we have x minus 0 squared plus y minus 3 squared equals the square root of 26 squared, which is just 26. We expand each of those binomials, so we would have, well, x minus 0 squared isn't so much to expand. We'll just have x squared. But on our next expression, we'll expand that one. We'll have y squared minus 6y plus 9 equals 26. And we do need to subtract 26 from both sides to put it in general form. So our equation is x squared plus y squared minus 6y minus 17 equals 0. So for our next example, let's write the standard form of the equation of a circle with center 4, 1 that is tangent to the line x equals 7. So again, we weren't provided with the radius, but we were given a clue as to the radius. So I will draw my picture again because it helps me think the problem through. The center is at 4, 1. 4, 1 is right here. And it's tangent to the line x equals 7. So let's get to 7. Remember, x equals 7 is a vertical line. Now, if the circle is tangent to the line x equals 7, remember that means it will just touch that line in one point. Let's draw it. I will do my best. So very roughly, it looks like this, with this right here being a radius from the point 4, 1 over to this point over here that is at 7, 1. So we can just look at this and tell that the radius is equal to 3. So let's write our equation. And notice I deliberately did not write the standard form and general form on this screen. Do you remember what they are? Remember, standard form is the form that we use when we're going to write the equation. General form is if we were going to multiply it out and set it equal to 0. This one only asks for standard form. So here we go. It is x minus the x coordinate of center squared plus y minus the y coordinate of center squared equals the radius squared. Now our radius is 3, so we'll square that and write 9. Since we were asked for standard form, this one is done. Let's do one last problem. For this one, we're being asked to write the standard form of the equation of a circle with endpoints of a diameter at negative 5, 1 and negative 7, 11. Notice this time I'm not given the center or the radius, so my job is to track down both of those things. Now, it doesn't ask us to, but I always like to draw a picture because it helps me think it through. So negative 5, 1 could be about right here. And negative 7, 11 could be here. So understand what it's asking us to do. It's to find the equation of the circle that has endpoints of the diameter at these 2 points. So I'm drawing a very rough sketch. That is super rough. But this is the diameter of the circle. So if I had drawn a better circle, you would see that the diameter always goes through center. So in fact, the center would be the midpoint of that line segment. So let's find it. The center, which is equal to, let me write it, the midpoint of the diameter. And you could, by inspection, look at those perhaps. Notice halfway between -5 and -7 is -6. And halfway between 11 and 1 is +6. And we could use that. But what if it wasn't obvious to you, or maybe it's not obvious on this one? Let's use the formula for finding the midpoint. Remember, it's the average of the x-coordinates, so -5 plus -7 divided by 2, and the average of the y-coordinates, 1 plus 11 divided by 2. So we would get -12 over 2 and +12 over 2, which gives us the point -6, +6. So we have our center of the circle. What we don't have is the radius. But now that we have centered, this point right here is -6, 6, and we have a point, in fact, we have 2 points on the circle. I can use this point right up here, -7, 11, and I can use the distance formula to find this distance, which we know is the radius. So our radius equals the square root of -7 minus -6 squared plus 11 minus 6 squared. We'll simplify, and we have the square root of -1 squared plus 5 squared, or the square root of 26. Now that we have the center and we have the radius, we can go right to standard form. We have x minus -6 squared plus y minus 6 squared equals the square root of 26 squared, which we'll just write as 26. And we have our equation finished.